Hey guys, this is Manak and this is the day 9 of this course on STAAD.Pro. We are working through a live project and today we are going to design the foundation. So let's get started. So first of all, for designing the foundation, you already have designed foundation separately in a video. You can watch that video, or if you want to practice along with it and match your results as you're practicing, you can do it here as well. So first of all, you'll go to loads and definitions, and the load definition we have defined load combination. These are factored load combinations. Now we have to generate unfactored load combinations. Unfortunately, there is no such option available in STAAD.Pro and also in ETABS also. Hopefully, they add in the further versions. But right now in the STAAD.Pro V8 I version 5, there is no option for the unfactored load combinations, so to generate them manually. So go to load cases and click on add here and define load combinations. You can select here. So first of all, the factor will always be one here, and the first load combination which I'm going to select is dead load plus live load. So one into dead load plus live load. You select both of them and click on add. And you have made a changes to structure, and the results will change obviously. And after that, the next load combination will be your dead load plus live load plus your earthquake load in x direction. Dead load plus live load plus earthquake load in x direction. This will be another load combination. Click on add here, and then there will be dead load plus live load minus this will be plus, and the minus seismic load in x direction, so this will be -1. And uh, and after that this will be it. So seismic load in x direction, and it is done. Then it will be dead load plus live load plus seismic load in z direction, and this will be +1. Everything will be +1 here, and this will be the case. And then we'll add this, and then another combination with dead load plus live load, and the seismic load in z direction. Now this one will be -1, and we'll click on this, and then we'll click on add. So pretty much all the load combinations, unfactored load combinations have been added. Dead load, live load, dead load plus minus, dead load and live load plus minus seismic load. This has been added, and close this. We'll analyze the model. There will be no changes because all these load combinations are lower, have lower impact than the load combinations which you had created earlier, because they are factored, they have higher impact. So no changes in the structure, but for continuing, we have to run the analysis once again. Save the file and run analysis. Anything won't change in the model, any error won't come. So we just close this, and after that we are good to go. As we had seen, that there were 4 bars of 20 mm in this design. I can see here there is 8 bars of 16 mm, and some places maybe 4 bars of but also there 4 bars of 20 mm. So no changes in the design as such. Okay, so now when we are when we have done with that, now for continuing, we have to design the foundation. So for designing the foundation, we'll go to the front view and we'll just select this nodes. So go to the node cursor and select the nodes here, and right click and then go to new view. And after that, just click on OK. Whatever the thing comes, go to the top view. And here, if you are seeing the supports, press Shift plus K here for turning on of the nodes, and Shift plus S to turn off the supports and turn on the supports, and Shift plus N to turn on the node number. So like this, you can just see the everything here. So this is pretty much it. Now you can design the foundation for a particular footing. We all have. I had given the foundation design and given the link of the this sheet in the description, so you can find it from here. I started footing design. Both tapered and normal footing has been designed. ISBC is 120, around 120 as far as I have confirmed from the client. And here we have to provide the load here. So for that, we'll do that. I'm just here doing here a new Excel sheet here. Microsoft Excel sheet. I'll do here rough, and then just open the sheet, Excel sheet. Okay. So after opening the sheet, we will just go here. Okay, slab design. Now, right now, we don't need to. So just close this. Okay, let's let it be there. No problem. We need it later. Okay, so now for the first node, maybe we'll design for this particular node the footing. So this is the first node which we have selected, and here you have this. We'll go to our post processing, and in the post processing here, this data range we need here for. So here range we need for the combination which you've selected, and shift select this, and we'll select this. Okay, load combinations which are we have made here. So and click on apply, and okay. Okay, so load combinations have been selected, no problem in that. And report, as you can see in the report, we have this beam property joint displacement support reactions. Exactly what we want is the support reactions. So just click on support reactions, and we'll click on report, and loading. In the loading, we'll select the loading which you want, combination load combinations. Shift select, and this load combinations which you want. Click on OK, and after that you have this forces kind of here. So what we'll do, we'll just copy all of them, select this, and just copy this, and we'll just open the blank page in Excel, and then paste it here. And now this we don't need, this also we don't need. Force in X direction don't need, force in Z direction we don't need, uh, moment in Y direction we don't need that. Okay, and right click and delete. We don't not interested in things which you don't need. So we'll use an Excel command equals to max of this particular things here, maximum of this, and we'll just copy, take it forward. And also since the negative sign is also there, so we'll also have to find a minimum also equals to a minimum of this. If the maximum is a negative also we take, and enter, and then let's see, we'll take like this. So along this magnitude, we consider the magnitude. This is higher 26, and this is higher in magnitude here, and again this is higher in magnitude here, ignoring the sign. 174, 30.26, and here 26.148. So coming back to the Excel sheet of the footing design, we first of all will insert here 174.729. Let's insert 175, right? 175. And then you can see here it is written M2 or MY. Now you can see the direction here, it is like this, and this direction, my friends, in STAAD.Pro is the Z direction. So this whatever MZ has come, we'll just put it here. So you can see MZ maximum is 26.148. Let's go here 26.2. Okay, so let's go here 26.2, right? And my, the remaining value, the last remaining value is 30.26. Let's go 30.3. Okay, so let's go 30.3 here, and this is it. And if you just fails, then you can increase this 1000. No need to otherwise to increase this. You can change this soil bearing capacity. And this backfill, my backfill will be of the footing. If the footing is minimum 300 mm, 1.5 meter depth I've taken, so fill will be 1.2. That's okay, right? Okay, so it's okay. 1.2 df fill, which is taken fill 1.2 meter, so it's okay. And now you can see here df is 1.5 meter. It is okay. Now, if you are to design a particular footing, which is of size, let's say of size 300 and 400, then then the size will be your, let's see, depth of 300, and the small depth is 300, and the larger one is 400. Then the size of the footing will be, let's see, here all the parameters are safe, meaning parameters are okay. So no problem with that, and the footing is passing. And column size also you can insert it 300 into 300, and the footing dimension, it is coming as 2300 into 2300. As you can see here, it is coming like this, 2300 into 2300. And let's see, make some changes and see if the value changes or something. So if we like a plain footing, 0.3 to 0.3, let's see. And this will be, this is not changed here, 2300, 2300. Okay, it's not changed. Let's go for 0.2 and 0.3. Then also it's not changed much. Let's do 0.2 and 0.5. Let's see. Then also it is not changed. So this is not changed. Let's keep it. First of all, let's keep it 0.3 and 0.4. First of all, we'll keep it like this, and then this one, this value will just reduce and see. Let's keep it 950, and still it's you can see this value is less than this value, so it's okay. 2200, it's good. Let's keep it 900, 2100, and you can see hence okay, everything is okay here until this value is okay. It's good. Let's give it 800 and see. So still now it is okay. Okay. Let's give this now 700. Now still now it's okay. It's coming close this value TV and all. Okay. This is showing redesign. So 750 redesign. 800. This is 800 redesign. 850. Okay. So in 850, it is okay. That is 2000 into 2000. If it's 2 meter, if you divide it by 3.28, it's around, uh, sorry, multiply it by 3.28, it is around 6.6 feet, the footing size. So it's around 2 meter. And the small depth, and this is 0.3 and 0.5, and diameter 10 mm dia can be used. And if you're using 10 mm dia, and in both direction, we can probably use 175 mm center to center. We can use because 200 and 196 it is there. So 175 mm center to center we can use for this. And let's see, other footings like this. We have to see other footings as well, and we have to check for all other footings, and then we can provide the grouping. So now you know how to design the footing and all. This will be it for the lecture. In the next lecture, and I'll finish the final drawings. I'll show you the drawings so that you can compare your drawings with mine and see where these changes are there and where you can improve, or if you think there is any suggestion to me also, you can also give. So that's all. And whatever you have learned in this lecture, if you have feel anything to say to me, just make sure my comment section is open. You can write in the comments below. Thank you. Have a good day. Bye bye. Keep learning.